All right, what's up, guys? If you are watching this video, that means I'm not at school today. Sorry about that. I had a meeting. So let's see here. This is the 5.7 notes. This is going to be the last thing that is on our test. All right, so I believe the last page on your test looks something like this. All right, it's gonna be like this problem. All right. So kind of proving stuff, kind of not, right? So these aren't going to be your typical two-column proofs. We're just going to classify these triangles based on the side length. All right. Well, hey, here's kind of the key word here, the side length. How can I tell how long two things are? Use the distance formula. So here, I don't want to write all that down. So up here, I'm just going to say in size 20 font, use the distance formula to find the lengths, LNG lengths of the sides of the triangle. Perfect. All right. What is the distance formula, you ask? Well, hopefully you would recognize this. D equals square root of x2 minus x1 squared. All right. Plus, we got y2 minus y1 squared. Right? And then we square root that whole mess. That is the distance formula. All right. Now, we're going to have to do that 3 times on this problem, right? Because we're going to have to figure out the length of GO, the length of GE, and the length of EO. Now, they're saying, hey, is it scalene? Is it isosceles? Or is it equilateral? So we need to know what all 3 of those terms mean in order to kind of prove this, right? The definition of a scalene triangle is none of these sides are the same length. The definition of isosceles triangle, at least 2 of the 3 sides are the same length, or they are congruent. And then the green one, equilateral, all 3 sides are congruent. So that's what we're going to show. Now, I realize the distance formula does take a long time, so let me show you some shortcuts. If I am looking for the length of GO, when we kind of first defined what what the distance formula was, we used the Pythagorean theorem. So if I wanted to go from G to O, it's a diagonal line, I have to figure out, okay, how far am I going horizontally? All right, and that's really easy to do. All we had to do was count those spaces. And if I look at that, I think that's 9. I hope that's 9. All right, it is 9. And then I have to go up 2 spaces. Right? So if we look at the hypotenuse on this triangle, that is the length of GO. How can we figure that out? Well, we know the Pythagorean theorem was a squared plus b squared equals c squared. And what we had to do is we needed to solve this for c. And in order to solve this for c, all we had to do was square root both sides, and we cancel out that square. So we are just left with c equals the square root of a squared plus b squared. That is our Pythagorean theorem. And we can do that instead of the distance formula. So that's exactly what I'm going to do here. So I'm going to start at point G, go to point O. That distance, that length, is the square root of 9 squared plus 2 squared. All right. And then we square that whole thing. Let's do the order of operations. We got the square root of 81 plus 4. All right, and then let's add everything on the inside here. That gives us the square root of 85. Now, if you throw that in your calculator, the square root of 85, some really ugly decimal. Okay, I don't know what that is. No one knows what that is. So we're just going to leave it as the square root of 85, right? That looks a lot more clean than 9 point something, all right? So the length of GO is the square root of 85. Now I'm going to do the same thing with GE, starting at point G and going to point E. All right, let's make another triangle here. So how many spaces up do I have to go, and how many spaces to the right do I need to go? let's see here. Just count them. 1, 2, 3, 4, 5, 6, 7, 8. I'm going up 8 spaces, and then to the right, 2 spaces. All right, so there we go. That's our distance formula. X is first, so the left and the right first. So let's say 2 squared plus 8 squared. All right. That gives us the square root of 4 plus 64. Right? Or that gives us the square root of 68. All right. So I don't know what the square root of 68 is, but what I do know is it's not the same thing as the square root of 85, right? Those are two different numbers. So just off these first two, we know we can say, hey, GO is not congruent to GE. All right, so we already know it's not an equilateral triangle, right? But it could be one of the other three. So we need to just confirm that. Let's figure out what EO is. So going from E down to O, let's count the spaces. So I'm going to the right 7, and I'm going down 6 spaces. That's why I have a -6 there. All right, so here we go. The square root of 7 squared plus, I'm going to put the negative in parentheses. You should always put the negative in your parentheses. So we got -6 squared. All right. And then let's see, 7 squared is 49. So I got the square root of 49 plus the square root of 36. All right. 49 plus 36 gives us the square root of 85. Well, hey, look at this. So we know EO is congruent to GO. All right, so what we did is we just proved, hey, triangle GEO is isosceles. All right, so let's write that down. GEO is isosceles. We know it's isosceles because it has 2 congruent sides. And that one's done. We just proved that this triangle here is an isosceles triangle. All right, now, the next one, same exact thing. The only difference here is I don't give you a graph. So we are unfortunately going to have to rely on the distance formula. So, all right, I know it sounds silly, but if I'm looking for VW, I need to use point V and point W here. All right, so we're going to have the square root of, I'm not going to write it down. We're using the distance formula here. All right, so kind of keep this in mind. That's what I'm going to be using on these next 3 problems. All right, difference of the x's. So we have 23 minus 4. All right, squared plus 24 minus -7 squared. We square root that whole thing. I think I need another square root. There we go. All right. No, that's not right. Let me try that again. -7. There we go. All right. Let me show you how, if you're using one of my graphing calculators, let me show you how you do this. All right. I am going to, everything that's underneath that square root, you can just throw in the calculator as is. So watch this. All right, look at what's underneath. I got 23 minus 4 squared. Nope. Take 2. There we go. 23 minus 4 squared. Okay, plus 24 parenthesis. Don't forget the parentheses.
All right.
24 minus, there we go, -7. All right, squared. So notice how I typed in this exactly how I saw it, except I did not put the square root symbol on there. I'm going to show you why. All right, this is a nice number. So 13, what is that? 22. 1322. So this equals the square root of 1322. 22. Again, that's a pretty big number. That might break down. I don't know. We could try. But I don't think it's necessary to do that. Like if I divide this by 4, is that going to give us something? Maybe. Let's see. All right, so it doesn't. All right, so that it might not break down. It might. I don't really want to take the time to check it, right? Because I just want to see what WX and XV are. All right, so this is some length. Again, if I punch that in my calculator, it'll give me some decimal. All right, so now on to the next one. We have to use point W and point X. So this is the square root of difference of the x's. So 7 minus 23, put that whole thing in parentheses, squared plus, do the same thing with y values, 0 minus 24, parentheses, and then close up the square root. And then again, if you want to punch it all into your calculator, you can do that. All right, so type it in exactly how you see it. All right. So 7 minus 23, close the parenthesis, press the squared button, put the plus button, another parenthesis, open it. 0 minus 24, close that parenthesis, press the square button. All right, so just make sure it looks exactly like you have it written down. So that's 832. Whoa. This equals 832, the square root of 832. All right, so just looking at that, we know VW is not congruent to WX. WX. All right. One more. We have point X and V, so I'm going to use point X and point V. So we have the square root of 7 minus 4 squared, and then 0 plus 0 minus -7. All right. And again, just following that same process, punch that into your calculator exactly how you see it, and you are going to get the square root of 58. All right. So we can establish here that WX is not congruent to XV. My computer is struggling, or is it me? It could just be me. I don't know. All right. So those two are not congruent. Also, look at these two. All right, the top and the bottom. W or VW is not congruent to XV. All right. So we have a triangle where all 3 sides are different lengths. What does that mean? By definition, that is a scalene. All right. It's scalene. Why is it scalene? Because none of the sides are congruent. All right, that is the definition of scaling. All right, so that was page 1. Page 17, I'm going to do page 18 in another video. We'll see you guys in the next one here. So how do I stop recording this? I gotta stop sharing, then I gotta end it. All right, see you next one.